straight line has equation 4x's plus 2y minus 7 equals 0. Find the equation of the line that is parallel. So the first thing is, we've got to find the equation of a straight line. So we've got to find the gradient and we've got to find a point. Now it tells us that it's going through the point -4, 1. So that's fine, we've got a point. But I don't have a gradient, but I'm told that it's parallel to that line there. So parallel lines have got equal gradients. So if you're doing this in a test, you write everything down. So parallel lines equal gradients. So the first thing you do is you have to get that line that we're given in a correct form. That's not the format that I can read the gradient from. So I've got 4x's plus 2y, take away 7 is equal to 0. I want 1y and everything else over the other side of the equal sign. So I'm going to take 4x away from both sides. That's the first thing. So 4x comes away from there. And I don't want that to take away 7, so I'm going to add 7 on to the other side. So that will leave 2y is equal to minus 4x's plus 7. Now I'm getting there, but still not 1y. So I've got to then get rid of this 2 times y. So to undo 2 times y, we divide everything by 2. So y is equal to minus 4 divided by 2x plus 7 over 2. Now the gradient there is minus 4 over 2, but that can be simplified. So y is equal to minus 4 divided by 2 is minus 2x's plus 7 over 2. So we can say that gradient m1 is equal to negative 2. So therefore, m2, the gradient we're looking for, is also equal to negative 2. Now I want the equation of that line. So the equation, gather up the information that I need. So the equation is, I need gradient is equal to negative 2, and I need a point on the line. And if I go back up, the point is it's passing through minus 4, 1. So the point is negative 4, 1. Now once I've got to that stage, it's no longer a higher question, it's a national 5. So y minus b is equal to m times x minus a. We'll sub in all the values, that will be a and that will be b. So y minus b will give me y minus 1 is equal to negative 2 times x minus 4 makes x plus 4. When I tidy that up, I'll do the bracket first. Y minus 1 is equal to negative 2x's minus 8. I want to get rid of that, take away 1 from that side, so I'll add 1 on to both sides. And that gives me an equation, y is equal to negative 2x's take away 7. Y is equal to the cubed root of x all squared. What is the y by dx? Now we've got to prepare this first because we've got roots and things in there. So that becomes y is equal to x to the power of. The 2 is stuck to the x, that stays there. Root, the cubed root, roots are underneath fraction, underneath the ground, so it becomes y is equal to x to the 2/3. Right, we now want to take the derivative of that. So we've got dy by dx, and dy by dx multiply by the power, take 1 away from the power, so it gives us 2/3 x, and we want to take 1 away from that, so I'll take it over here. 2/3 take away 1, we're dealing in thirds, so it's 2/3 take away 3/3, which is equal to 2 of them take away 3 of them is negative 1 of them, and we're talking about thirds, so it's minus 1/3. We want to work out the equation of line L1, which goes through the point negative 2, 5 and is perpendicular to the line L2 with equation that. So to work out the equation of a straight line, we need a gradient and we need a point. We've got the point is negative 2, 5. I don't have a gradient, but I'm told it's perpendicular to that line. So we have to work out the gradient of that line first. And if it's perpendicular, the 2 gradients multiply to give you negative 1. Quick way to work that out is change the sign and flip. So we've got 2x's minus 4y plus 3 is equal to 0. Now, because that's a negative 4y, I'm going to add that onto the other side, or onto both sides. So when I add 4y onto both sides, I'm left on this side with 2x plus 3 is equal to 4y. I'll read it round the other way, so 4y is equal to 2x plus 3. So therefore y is equal to, divide by 4, so it's 2 over 4x plus 3. And 2 divided by 4 is equal to a half. So y is equal to half x plus 3. Now, I decided to add 4y onto that side rather than changing everything and dealing with negatives. These wee things you'll learn as you're going along. So it's perpendicular to that line, so we'll say that m1 is equal to a half. We'll write down m1 times m2 is equal to negative 1. That means we can flip and change the sign. So when I flip the gradient of that one, I flip it and I get 2, but I've got to change the sign. So m2 is equal to negative 2. Now I'm ready to do the equation of the line that they ask for, which is L1, but that doesn't really matter. You don't need to worry about that. So I've got the gradient is equal to negative 2, and it passes through the point. We'll go back and have a look. Negative 2, 5. So it passes through the point negative 2, 5. So we'll label that. That will be A and that will be B. So we're back again to our national 5. So y minus b is equal to m times x minus a. So therefore y minus b becomes y minus 5 is equal to negative 2 times x minus 2, so it's x plus 2. Multiply out the brackets, so y minus 5 is equal to negative 2x's minus 4. Don't want that negative 5 to be there, so we'll add 5 onto both sides. And when I add 5 onto both sides, the equation I get is y is equal to minus 2x's. And when we add 5 onto that, we get plus 1. That's the equation of a line. Now there's another part, part B. So for part B, it says, show that the point 5, negative 9 lies on this line. So we've got to show that the point 5, negative 9 lies on the line with equation y is equal to minus 2x plus 1. So what you do is you calculate the y coordinate. So calculate the y coordinate. And once you've done that, you then compare. So calculate the y coordinate. Right, so how do we do that? We know the rule is y is equal to negative 2x's plus 1. So I'm going to do negative 2 times 5, so x is 5, put that in there. And negative 2 times 5 is negative 10. Negative 10 plus 1 is equal to negative 9. That's what we wanted. So we can say, since y equals negative 9, point lies on the line. Okay, so if you get a question like that, you substitute the x coordinate into the equation and you compare the y coordinates. If they're the same, then the point lies in the line. If they are different, the point does not lie on. Okay, next question. It says fx is equal to 1 over x bracket x to the power of 4 minus 2. What's the value of f dash negative 1? So that means that we've got to take the derivative. And once I've got the derivative, I've got to substitute x equal to negative 1. Okay, now we're going to look at that. That's got to be prepared. That's not in the correct format. So we'll multiply out the bracket. So fx is equal to 1 over x times x to the power of 4. So if I do 1 over x multiplied by x to the power of 4, that's equal to x to the power of 4 divided by x. That's x to the power of 1. When you're dividing indices, take 1 away from the powers. So that is going to give me x to the power of 3. When I multiply that, I've got 1 over x multiplied by negative 2. We pretend that we're multiplying straight across the top, straight across the bottom. Pretend that's over 1. So that gives me negative 2 over x. So that's the first stage in our preparation. But I've still got a problem because I've got an x in the denominator. Cannot do that, so I've got to bring that up to the top. That is x to the power of 1. So when we bring that up to the top, that will become minus 2x to the negative 1. So we're now ready, it's all prepared, that's fx. We will now do our f dash x. So f dash x multiplied by the power, take 1 away from the power, gives me 3x squared. Multiply by the power, take 1 away from the power, that becomes plus 2x to the negative 2. Now I've got to substitute in minus 1. I don't like this negative power, so I'm going to write this out properly. So 3x squared is fine, we can substitute into that. But this one, I've got to drop the x to the negative 2 down to the bottom to make it x squared. Now it's okay to substitute your number in. So f dash negative 1 is going to become 3 times negative 1 all squared plus 2 divided by negative 1 all squared. So negative 1 squared is 1, 3 ones are 3, and I've got to add on 2 divided by negative 1 squared is 1, so that becomes 2 over 1, which is just 2, so the final answer is 5. Find the coordinates of the points of intersection of the lines 3x minus y equals 7 and x plus 2y equals 0. So when you're trying to find where two straight lines cross, it's just a simultaneous equation. So we've got 3x minus y is equal to 7, and we've got x plus 2y is equal to 0. So we can either eliminate x or y. I'm going to eliminate y. So that's 2y, so I need to multiply that equation. So equation 1, I'm going to multiply by 2. And when I do that, I get 2 times 3x is 6x. 2 times negative y is negative 2y. And 2 times 7 is 14. Now that means at the bottom equation, they've got the same numerical value, the same number in front of them. One is positive, one is negative. So when we have got different signs means that we add, it's a dad's one. Different sign means that we add. So I want to add those two equations together. So I've got 6x plus 1x is 7x. I've got minus 2y plus 2y, they cancel each other out, and that was the whole point of it. And we've got 14 add on 0 is 14. So if 7x's are 14, then x is equal to 14 divided by 7, which is 2. Now we're going to sub to find y. So sub x equal to 2 into, go back to one of the initial equations. I'm just going to do x plus 2y equals 0. So x is 2, so 2 plus 2y equals 0. I want to add, sorry, I want to take away 2 from both sides. So I'm taking away 2 from there, I'll take away 2 from there. So that means that 2y is equal to negative 2. I don't want 2 times y, so I'm going to divide both sides by 2. So y is equal to negative 1. So the point for these two straight lines cross is the point 2, negative 1. Question 6, a differentiation again, is worth 3 marks. This thing is not prepared. There's brackets, there's squares, so we need to get rid of all of that. So we always square the bracket first. So y is equal to x, and I'm going to do the quick way to square a bracket. So square the first is x squared. Multiply the two of them together and double it, so minus 2x doubled, so minus 4x's. And square the last, negative 2 times negative 2 is plus 4. Now I need to multiply all of that by x. So that gives me x cubed minus 4x squared plus 4x's. It's now prepared. I can now take the derivative. So I change y to dy by dx. Take the derivative, multiply by the power, take 1 away from the power, so 3x squared. Multiply by the power is minus 8x to the power of 1, which is just x. And then the derivative of 4x, the x's disappear, and it's just plus 4. And that's it all done. Question 7. These are really important questions, finding the equation of a tangent to a curve. So we want to find the equation of a tangent. A tangent is just a straight line. Two things we need to find the equation of a tangent. we need a point, we need the gradient, and then we can do the equation. Now what happens is they tend to just give you the x coordinate of the point. There we've got it there. So we want to find the equation of the tangent to that curve. So we'll do point, we'll do gradient, and then we'll work out the equation. Okay. So first thing we're going to do is we know that x is equal to -1. So I know that point is -1 something, but I don't know the y coordinate. But I do know a rule for y. There, it's there. Y is equal to x to the power of 3 minus 4 lots of x's. So they tell me a rule to work it out. So when I substitute -1 in there, I've got -1 to the power of 3 minus 4 times -1. -1 to the power of 3 is -1. -4 times -1 makes +4. And that means that's the same as 4 take away 1. So the point is 3. Okay, so I can go back there and I can fill in the y coordinate. So y coordinate is 3. Now I want a gradient. So the gradient is equal to dy by dx, the derivative. So we'll work out the derivative. So multiply by the power, take 1 away from the power. Derivative of that becomes -4. Now we're doing the same thing again. We're substituting this x equal to -1 into this equation because gradient is a number. So it's 3 times -1 all squared, take away 4. -1 squared is 1, 3 lots of 1 is 3, 3 take away 4 gives me a gradient of -1. So now I've got the gradient and I've got the point. So therefore I've got -1, 3, and I've got the gradient is equal to -1. So y minus b is equal to m times x minus a. So y minus b becomes y minus 3 is equal to -1 times x minus -1, so it's x plus 1. So y minus 3 is equal to -1 lot of x, which is just -x. -1 times +1 is -1. Don't want that -3 to be there, so I'll add 3 onto both sides. So I'll add 3 onto that side and I'll add 3 onto that side, and that will give me my final equation. So y is equal to -x. That's the same as 3 take away 1, so it's -x plus 2. fx is equal to 1 over x squared minus 4. Gx is equal to 2x. If hx is equal to f of gx, write down an expression for hx. So hx is equal to f of gx. First thing we do is we substitute the formula for gx into that bracket. So gx is equal to 2x, so that goes in there. Then we look to see what function f does to the thing in the bracket. So function f, you write down 1, and it's the thing in the bracket all squared, take away 4. So that will be equal to 1 divided by 2x all squared minus 4. So we want to tidy that up a wee bit, so that's equal to 1 over 2x times 2x is 4x squared, so it's 4x squared minus 4, and that gives us hx. Then it says we've got to suggest a suitable domain for that function. So that means we want to find numbers that we can substitute into that. Now there's two things in maths you can't do. You can't divide by 0 and you can't take the square root of a negative number. So if you look here, we are dividing by this thing here. So we're dividing by that. So that means then that that cannot be equal to 0. So we've got 4x squared minus 4 cannot be equal to 0. So we're going to solve that wee equation. I'm going to add 4 onto both sides, so 4x squared cannot be equal to 4. 4 times x squared, I'll divide by 4, so x squared cannot be equal to 1. Now at this point you've got to be careful. So x cannot be equal to plus or minus the square root of 1. So x cannot be equal to 1, and x cannot be equal to -1. Now the reason for that is if I do 1 squared is 1, but also if I do -1 times -1 is also equal to 1. So when you take a square root, you've got a positive root. and you've got a negative root. So the suitable domain is any values of x, except for you cannot use x equal to 1 and you can't use x equal to negative 1. So a function f has a derivative, f dash x is equal to that. The graph of f has a stationary point at that point there. What is the nature of this stationary point? Right, it's only worth 2 marks, so it should not be a difficult question. Numbers look horrendous. That does not look a good set of numbers to use. They've already given me the derivative, so I don't need to take the derivative. Okay, and I don't need to set it equal to 0, and I don't need to work out the values. So basically this question is just asking me to work out the nature, so I can go straight on to the nature table. The x value is a horrible number, so we're going towards negative 4 over 3, and we're going away from negative 4 over 3. And we want to look at f dash x. So f dash x is 3 lots of x squared minus 2 lots of x's minus 8. Now, that's negative 1 1/3. I'm going to be extreme, and I'm going to use negative 10, because that's an easy number to use, and it's definitely well below minus 1 1/3. I want a number bigger than negative 1 1/3. I'm going to use 10. So pick numbers that are easy for you. You could use 0 in there as well. Okay, so 0 could be in there too. Right, so we know that that's a stationary point, so we know it's equal to 0 in there. So negative 10, if I'm substituting negative 10 into there, I'll just write this down here just now. So that's negative 10. Okay, so when I put negative 10 into there, negative 10 all squared is 100. So that gives me 3 times 100 is 300. And then I want to take away 2 lots of negative 10. So negative 2 times negative 10 gives us plus 20. And then I'm taking away 8. That's definitely positive. Now I want to do x equal to 10 or x equal to 0. You could use whatever. So we've got, we'll use x equal to 0. Right, so if x is 0, x squared is 0, x's are 0, and we've got negative 8. So therefore, that turns out to be negative. So we can fill that in. Okay, so if x is equal to 0, that becomes 0, 0, and negative 8 is minus. So that means I've got a gradient that goes up, a gradient across, and a gradient that goes down. So I've got a maximum turning point at that point, which was minus 4 over 3, and what was it, 500 over 27. Now, first of all, I thought I'd put 10 in there, but putting 10 in there makes that positive, which means that there must be another turning point in between them. You're not told that. Okay, so that's as much as we can do with information from that one, and it shouldn't be too difficult because it's only worth 2 marks. Okay, question 10, it says f in terms of u is equal to 1 over u plus 5 and gu is equal to 1 over u minus 5. Find a formula for f of gu. So we take the formula for gu, we substitute it into the brackets, we leave f where it is, so it becomes 1 over u minus 5. Now I want to find out what the function f does to the thing in the bracket. So function f does 1 over whatever is in the bracket plus 5. So that becomes 1 over the thing that's in the bracket, so that's 1 over u, take away 5. But then I've got to add on this 5, and it gives me that. Bit messy, but we'll tidy it up. Negative 5 plus 5 disappears, so that gives us 1 divided by 1 over u. Now, all you have to do is multiply top and bottom by u. So 1 times u is u. So I want to get rid of that horrible fraction at the bottom. So multiply by u at the top gives us u. And when I multiply that by u, I've got 1 over u multiplied by u. They cancel each other out and it becomes 1. So that just becomes u. Question 11. We want to solve the quadratic inequation. Now, as soon as you see solving a quadratic equation, you've got to draw a sketch. So we've got to draw a parabola, because that's the only way we can read off the answers from this. So the first thing you do is you have got to factorise this. So we want to factorise 2x squared plus 5x minus 3. I'm going to do it the quick way. So two things that multiply to give me 2x squared is 2x and x. Numbers that multiply to give me 3 are 3 and 1. One of them's got to be negative, one of the factors. So I'm going to try 3 in there, and I'll try 1 in there. 2 times 3 is 6, and I've got to make that positive, and I've got to make that negative. Right, now, if you need to do that the long way, then do it, that's okay. So what that tells me is I've got a parabola, and we pretend that that's equal to 0, so we've got 2x minus 1 equals 0, and we've got x plus 3 equals 0. So that gives me roots at 2x equal to 1, x equal to a half, and that gives me another root at x equal to negative 3. It's a U-shaped parabola, it's a happy one, it's positive. So we draw a parabola. There's the x-axis, there's the y-axis, and I want to draw one that's got roots at negative 3. So that's negative 3. It's only a sketch, so it doesn't matter, it's not drawn to scale, and that's a half. So we've got a parabola, and we'll just take it through our two roots, like that. Now, we're going to look and see it was less than or equal to 0. Now, that's normally y, so that's telling me y is less than or equal to 0. That's the y-axis. So y is less than or equal to 0 when any bit is below the x-axis, because that y-coordinate would be 0, negative 1, negative 2, negative 3. So we highlight the part of the graph that's below the x-axis. So it's all of that part of the graph. Now, how would you describe that part of the graph? That part of the graph has got all the x values in between negative 3 and a half. So write it down like that, and then your arrows go in the same direction as you're doing your limits when you're working out a limit to see if a limit existed. But it's also equal to, so you do less than or equal to, less than or equal to, and that's you solve that one. Find the quotient and the remainder when dividing that polynomial by x minus 2. So set up your grid, your nested calculation. That's 1, 6, 3 and 1. If that's x minus 2, the x value is plus 2, so put that outside your table. Drop the 1 down to start, and then multiply going across the table by that number. So 1 times 2 is 2, add up and down the way, that's 8. Multiply across the table, so 2 8s are 16, add up and down the way is 19. Multiply across the table, so we want 2 lots of 19, and 2 lots of 19 is 38. Add up and down the way, and the final box gives me 39. So we want to read off a remainder. So the remainder is at the end. So the remainder is equal to 39. And we want to read off the quotient. This is the quotient across here. That's the coefficients of the quotient. So we write down our x's in it. So it started off as x cubed, it drops a power of x, so that's 1x squared. That's x's and that's numbers. If it's positive, just stick the pluses in. There's no sign there. So your quotient is x squared plus 8x plus 19. Now, you can put all that together. You're not really asked to do this, but that bracket there was x minus 2. So you've got x minus 2 multiplied by the quotient is x squared plus 8x plus 19. And the remainder is something that's added on, so it's plus 39. And that's what that whole thing is equal to. So for this one, we have got find p given that x plus 3 is a factor of that expression. So we start off with the coefficients. So there's 1 lot of x cubed, there's negative 1 times x squared, there's p times x, and there's 15. Now the x plus 3 is the factor, so the x value is negative 3. Drop the 1 down to start, so that gives us 1. 1 times negative 3 is negative 3. We're adding them together, so negative 1 plus negative 3 is negative 4. Negative 4 times negative 3 gives us plus 12. Add them up and down the way. So that gives us 12 plus p, or p plus 12. Now I've got to multiply that by negative 3. I'm just going to do it in 2 stages. P times negative 3 is negative 3p, and negative 3 times 12 gives me negative 36. Now I want to work this whole thing out, and I know it's a factor, so I know that's got to be equal to 0. So when we add them up, we get minus 3p, and I've got 15, and I want to take away 36, and 15 take away 36 is minus 21. So minus 3p minus 21 is equal to 0, and it's equal to 0 because that's a factor. Solve that with the equation, so minus 3p equals 21, divide by negative 3, so p is equal to negative 7. Question 14, write 3x squared minus 3x minus 10 in the form. So that's to complete the square. Now you did this in National 5, but you only ever did it with 1x squared. So we've got to get that in the form, but it's only just 1x squared. So whatever this number is here, that 3 has got to come out as a factor. So pull it out of the x squareds and the x's, so that becomes x squared, and divide that by 3, and that becomes minus x. The minus 10 is outside the brackets, we're not interested in that just now. So square brackets for completing the square. Now we're going to complete the square inside those brackets. So what we do is we halve the number in front of the x term. So we're going to get a fraction this time, but it's okay. So half of negative 1 is minus a half. So that goes in the bracket. Then I've got to take away minus a half all squared. So when you square a number, it's positive, and we're just going to multiply straight across top, straight across the bottom. So that's 1 over 4. So we want to take away 1/4. And then we've got a minus 10 there. Next thing you do is you multiply that 3 back across. So 3 bracket x minus a half all squared. And 3 times minus a quarter is minus 3/4. And we've got minus 10. Now if this was in a non-calculator paper, we need to tidy this bit up. So we've got minus 3/4, and I want to take away 10. Now if I change the 10 into quarters, then I've multiplied the bottom number by 4. So I've got to multiply the top number by 4, so that becomes 40. So I've got minus 3 of them, take away another 40 of them is minus 43. So at the end, I've got minus 43 over 4, and that bit just stays the same. Now, I'm going to ask a wee extra question here. What's the turning point of this parabola? So turning point, change and keep, which is a half, minus 43 over 4. Now, sometimes you're asked a minimum value or a maximum value. You're not asked it here, but you could be. So that is just asking your y coordinate. So this is a happy one, so it looks like that. That turning point there is at a half, minus 43 over 4. So the minimum value of that is just the y coordinate. So minimum value is equal to minus 43 over 4. So if you're asked a maximum or a minimum value, it's the y coordinate of your turning point. That's all that means. Section B, calculator allowed for this one. It says a straight line has equation, and it gives us that. It says find the angle that this line makes with the positive direction of the x-axis. As soon as I see the positive direction of the x-axis, I know that it's something to do with gradient is equal to tan theta. That's the key for that wee bit. Now, it says we've got to find the angle, so I want to find this tan theta. I'm going to write it round the other way. But I know tan theta is equal to the gradient, so I need to find the gradient of that line. It's not in the correct format, so we'll change it. So I've got 3x's minus 6y minus 7 equals 0. Now, I want y equal to something. I'm seeing that negative y again. I'm going to add that onto both sides. And when I add that onto both sides, I'm left with 3x minus 7 is equal to 6y. I can now read it round the other way. 6y is equal to 3x's minus 7. I don't want 6 times y, so I'm going to divide by that 6. So y is equal to 3 over 6 x's minus 7 over 6. Now 3 over 6 is a fraction. It can be broken down to 1/2. So the gradient of this line is equal to half. So that means that tan theta is equal to half. I want to shift that tan away. So on your calculator, do shift tan and do shift tan and put in your half, and it'll give you theta is equal to 26.6 degrees. Y is equal to x to the power of 4 minus x divided by x cubed. Calculate the rate of change of y when x equals 1. That's just a fancy name for find the derivative and then substitute in x equal to 1. So if you see a rate of change, you take the derivative and you substitute the x value in that you're given. So that's all it is. Now we need to prepare that because that's not prepared. Now I'm seeing a string of things there all over a value. So the keyword for that is split. So I've got x to the power of 4 divided by x to the power of 3. And I've got minus x over x to the power of 3. Now we've got to work that out. So we're dividing indices. We subtract the powers. So x to the power of 4 divided by x to the power of 3 gives me x to the power of 1, which is just x. And then I've got minus x to the power of 1 divided by x to the power of 3. So take the powers away, so that'll give me x to the power of negative 2. Now I can take the derivative. So change to dy by dx. And the derivative of x is just 1 because it's 1x. Multiply by the power, so minus times minus 2 gives us plus 2. And it's x to the power of, take 1 away, so negative 2, take away another 1 is negative 3. Now I want to substitute a number in, so I don't like negative powers. So it's 1 plus 2 stays as it is, and we drop the x to the power of 3 down to the bottom. So the rate of change is just that, but we've got to substitute a number in. So rate of change is equal to 1 plus 2 over x cubed. And it's the rate of change when x is equal to 1. So we substitute 1 into that. So 1 stays as it is. And then I've got plus 2 divided by 1 to the power of 3, which is 1 plus 2. So the rate of change is equal to 3. So when you see rate of change, you take the derivative and you substitute in your value for x. Fx is equal to k x cubed plus 5x minus 1. If f dash 1 is equal to 14, find the value of k. Right, so you'll get questions like that are not always dead obvious at the start, but it's talking about f dash. So we're going to work out f dash x. So f dash x, we've got kx cubed multiplied by the power, take 1 away from the power, is 3kx to the power of 2. The derivative of 5x is plus 5. And the derivative of negative 1, it disappears. So they're telling me that f dash 1, so that means that x is equal to 1. So I'm going to put 1 into that. So f dash x is equal to 3k times 1 squared, which is just going to be 1 plus 5. So when I tidy that up, I've got 3k plus 5. That's the derivative of that whole thing when x is equal to 1. But then they told me an answer. They told me it's equal to 14, and we want to work back and work out what that is. So 3k plus 5 equals 14. We'll take 5 off both sides. So 3k is equal to 9. Divide by 3, k is equal to 3. Here's another one, find the equation of the tangent to the curve. So again, equation of a tangent to a curve. So what we want is we want point, gradient, and equation. Okay, now they're saying at the point P2 216. So I've got the point, don't need to do anything there. Normally you have to work out the y coordinate, but they've given you it, so it's there. So I want the gradient. So gradient is dy by dx. I'm going to look up here. That's not in a format that I can take the derivative of. So I'm going to take that x and make it x to the -1. I'll write it down here so we can see it. So y is equal to x squared plus 24x to the -1. So the derivative of that is multiply by the power, take 1 away from the power. So it's going to be 2x's. Multiply by the power, take 1 away from the power. So it's going to be minus 24x to the -2. Now I want to substitute a number in there. So I need to get rid of that negative power. So I've got 2x minus 24 over x squared. Now, we'll always substitute in the value for x because the gradient is a number. So x value is 2, x is equal to 2. So therefore the gradient is equal to 2 times 2 minus 24 over 2 squared. 2 2's are 4. 2 squared is 4. 24 divided by 4 gives us a value of 6. So 4 minus 6 is equal to -2. So gradient is -2. So now for the equation, gather my information. I've got the point 216. So that's A, that's B. And I've got the gradient is equal to -2. So y minus b is equal to m times x minus a. So we've got y minus 16 is equal to -2 times x minus 2. So y minus 16 is equal to -2x's. -2 times -2 is plus 4. We've got one last wee bit to tidy that up. I don't like that take away 16, so we're going to add 16 onto both sides. So y is equal to -2x's. 16 plus 4 is plus 20. And that's the gradient of the tangent to the curve. So another completing the square. So we want to complete the square of 3x squared plus 6x plus 33. So we're going to take out that 3 as a common factor. So 3x squared goes in there. Divide the 6x by 3 gives us 2x's. Leave the 33 out of the bracket. We're now going to complete that square inside that. So 3 is still out there. We're going to half the number in front of x. So it's going to give us x plus 1 all squared. And we've got to subtract that 1 squared away. So I'm taking away 1. And plus 33 is still sitting out there. Get rid of the 3. So it's 3 bracket x plus 1 all squared minus 3 plus 33. So that will give me 3x plus 1 all squared. 33 take away 3x plus 30. And that's the square has all been completed. The next part of this question is going to ask me about a maximum value of that thing there. So I'm going to go back, I'm going to look at this, because that's what we're talking about. That there is a happy parabola, so it looks like that. It's got a turning point, change and keep. So it's got a turning point there at -1, 30. So that means it's got a minimum value. And remember, it's always the y number. So it's got a minimum value of 30. Now, for the second bit of this, it says, hence find the maximum value of 1 over. So I want to find the maximum value of 1 over 3x squared plus, what was it, 6x plus 33. All you do for that is, you do 1 over, and whatever your maximum value or minimum value of this is, you put it in, you substitute it in. So we know it was 30, so it's 1 over 30. Now, in the question it's saying here, it's a maximum value. That's right, it is a maximum value because you've turned that parabola upside down. It's become 1 over that thing. So you flip that, so you flip the parabola and it ends up as a maximum value of 1 over 30. So that's why it changes from being a minimum value to a maximum value. But you don't really need to worry about that, but in case you're confused about it.